x and y. So you have 0 to A, 0 to B, right? That's the rectangle, right? And then supposedly the boundary condition should be 0 because it said this fixed membrane, so size 0, size 0. The four boundary condition is 0, right? And to solve the wave equation within the square, so you have a 2D Laplacian equation plus x squared plus y squared, and then depends on what you want. Is there specified what the other parameter? Yeah, it's I was just looking whether the question gives you any given parameter, right? It's not given to you, right? Yeah. Just assume a certain speed, certain wave speed, constant wave speed, right? That would be your wave equation. And now you can write down your solution because of the zero boundary condition on all sides. So you're pretty sure that you can write this psi as x, y, t, and x and y is probably just what we used to do, and m and n from 1 to infinity, and from 1 to infinity, finally you have t part, right? And then this is separable, so you have sine m pi x over a sine n y over a. That would satisfy the x and y boundary condition that is 0, right? That would do it, right? And then you have a function t you need to solve, right? And to solve it, is just plug that back in this equation, and these two terms will give you the minus m pi a squared plus minus m pi over b squared. So that gives you two constant over multiplied by t, and then minus 1 over v squared b squared t dt squared. Right. So it means that this is like because if you multiply this to the other side, this is like a simple harmonic oscillator, except that we all have negative sign. If you like, you can now change all the negative sign to positive sign, because the right hand side is 0. So change all the positive, right? And that becomes a simple harmonic oscillator, where you see that, right? This is like a simple harmonic oscillator. So you say the t, you can just write down t as just some kind of parameter a and b, right? A sine omega n b plus b sine omega n b, right? And the omega mn, you plug that back in, becomes omega m n square equals to, because each time you take a second derivative, you pull a minus omega square, right? Minus omega square equals to whatever this one multiplied by v. This one. V square. Right? Did you get something like that?
thing m del square pi by del x square is m del square pi by del y square is equal to 10, and m square plus n square should be equal to l square. Like how we solved it, we didn't write it as n.
Well, that what you're saying is just this equation, right? So the frequency satisfy this relation, right? Whatever the frequency of the vibration in time satisfy this relation, right? And then this depends on m and n. I mean, your question has a few steps. You follow the step, you essentially getting the same solution. You follow the steps. Yeah. That I think this is up to part B. That will give you the solution up to part B. I mean, this is, I'm just writing it without going through the separable variable argument, because you already know that. You know, this is just a separable solution, t, x, and y, right?
When
just
we try to do separable variable, we got hyperbolic.
Why will you get hyperbolic? It shouldn't be. I mean, sometimes you get confused by those constants. I mean, by default, sometimes you set one is minus k squared, the other is k squared. That would just give you a confusion, because you determine whether they are positive or negative by your problem, not by whatever the sign that. Let's say you set it to k squared or minus k squared. It doesn't matter. Right? So it's k squared doesn't mean this is negative. It can be positive. You're just saying that it's minus k squared. It's just by so sometimes it's better to not use a k square. The textbook already use a k square or minus k square, that kind of language. That would sometimes confuse you that that must be positive, that must be negative. But in fact, it's just a constant. So this is like C sub 1, this is C sub 2, this is C sub 3, right? And then not exactly like that. I mean, you need to do a separable argument first. But what I'm saying is those constants don't get confused by the default assignment of the variable. It doesn't have to be positive or negative. Is that okay? Probably if you choose a wrong side of office, you don't get sine, you get sin or something like that, or gosh, right? So, but the problem, because of the boundary condition, you pretty obvious that they should be oscillatory. I think, in fact, your question asks you for part C is to just sketch a few of these frequencies, right? It's trivial, right? So the fundamental CO to A will be the CO n equals to 1 term, right? N equals to 2 will be something like that. Right? And so on. So you know how to do that. Right? And if A equals B, then you can have a degeneracy that's trivial, right? But just if there's if A equals B, obviously different n and different m would give you the same frequency. So that's degenerate. Okay.